Good morning, everyone, and welcome to our methylation basics class that we're going to be running this morning. We've got a great weekend lined up for you at the 2018 Methylation and Genomics Summit, and it's fantastic to see so many of you here today. So we've got a lot on. We've got the rest of the 3 days with the conference itself, and so let's get started. Methylation is important. And we often have practitioners ringing and saying, well, I spoke to, one of my patients spoke to a GP and they said, oh, this is a lot of hoo-ha. It's actually biochemistry. It's not hoo-ha. It is simply biochemistry. And unfortunately, I don't think that doctors get a really good background in biochemistry. And I certainly know from lecturing all around the world that the naturopaths, nutritionists, the chiropractors, the integrative doctors know a heck of a lot more, because you see the eyes glass over when you start to talk about biochemistry. So methylation is understanding the biochemistry. And because it's the linchpin of where we need to go to make all these fundamental pathways work, for me, it is the starting place. And from a clinical perspective, if you address it, you will see changes that you never actually expected you would. So we're going to go through the pathways, and we're going to look at perhaps what our first steps should be. Particularly, that's the number one question. I have so much information here, and I have chronically ill patients. I've got 55 tests. Where the hell do I start? And I think that's probably one of the biggest things. Testing, we'll look at some of the testing and what we do, and we'll also look at some case studies. So just a quick look. Gene, obviously it's a sequence of nucleotides. When we're looking at research, it's actually very difficult because sometimes they're actually reporting on a DNA base change. So we have DNA bases that make up a gene, and essentially a mutation or a polymorphism is something that's different from what it should be. So in the case of MTHFR, we have a cytosine being changed to a thymine. It's a change. It's a change in a DNA base, which causes a change in an amino acid sequence, which has a downregulation of that particular enzyme. So, and then the allele is really how it differs from the norm. So you can actually have a polymorphism that 70% of the population have. It's actually different from the norm. But there may be no clinical significance. And a SNP, I think you all know by now, is a single nucleotide polymorphism. So on average, they occur in every 300 nucleotides. There's a heck of a lot of SNPs. And as I said, some have make no clinical difference or change. Some have a big change. Some will confer to a disease, but very few. And as you can see on the right there, I'll see if this might be, yes, this is my pointer. You can either, the outcome of and we say mutation. So mutation, when I started talking about this 8 years ago, you could easily say mutation. Now people say, well, you can't say the word mutation. We can't have mutants everywhere. We definitely can't say mutation. So we now say polymorphism, so that, and all it essentially means is it is different to the norm. Okay? So they don't want us calling people mutants. And so we can get a non-functioning protein. That's going to have a significant effect. A protein that is partially functional, one that has a completely new or different function, no protein at all, or no change. And it's really the epigenetics that's the exciting part, because, is my mic making funny noises? Is it all right? Yeah. From an epigenetic point of view, essentially what it means is that our environment can actually make changes to the way
our genes act. It can't change our DNA, but we do know that it is the epigenetic or the environmental influence that can change the way a gene acts. A really good example of that is the PON1 gene. So the PON1 gene is a gene that helps encode for an enzyme that gets rid of pesticides and organophosphates. It's very significant, I think today. It's probably one of the most important SNPs that I look at. And if I see that that is homozygous, the first question I'm going to ask my patients is, where were you when your mother was pregnant? Where did you grow up? And often you will see or hear them say, well, actually, I was born on a farm. And what sort of crop was in that area at the time? Oh, we're from Queensland, so it was essentially cotton crops or sunflower or potatoes or safflower, any of those that are highly sprayed with glyphosate. So what has that meant for that particular person? And the interesting thing about the PON1 gene is that babies do not develop the enzyme until they are 3 to 5. So if mum is exposed, the child is exposed in utero, and then they are exposed to it in that 3 to 5 before the enzyme gets into gear, for want of another word, that's a problem. And that's often where you will see, and we'll talk a lot about on the weekend, where's your start point? What was the trigger? And if you look, you will always find it. You have to be that medical detective and find out where did it start. And you will always find it if you ask the right questions. So it's the environment that causes the trigger. If that person had had PON1 homozygous and had really lived in the city and hadn't been exposed to toxic chemicals, had eaten an organic diet most of their lives, hadn't been exposed, then maybe there was no issue. So you see how the environment will impact your genetics, and that is the key. So you can see from this Ben Lynch's chart here, we actually get, you can see that here's your environmental causes. So everything from chemicals, aging, drugs, etc., has an epigenetic modulation, can cause a methylation deficiency. We can get damaged RNA, DNA, and that's when we get the altered gene expression, gene instability, and then potentially chronic disease. So MTHFR, so I'm sure you all know what it is by now. It's an enzyme that helps us make our active folate. And that's the best way I describe it to my patients. It is an enzyme that helps you create active folate. So what? Well, what does active folate do? Methylfolate. It helps make SAMe. And what does SAMe do? It is our universal methyl donor in the body. Any enzyme that is a methyl transferase cannot work without SAMe. DNA, detoxification, estrogen metabolism, creatine synthesis, phosphatidylcholine, we could go on and on. There's about 80 methyltransferases. So unfortunately, the polymorphisms mean that there is a downregulation in the MTHFR enzyme. So there's actually 30 different MTHFRs, and we're finding more and more research about the different ones every year. But the two that we know the most about are the A1298C and the C677T. So you can see, as I said before, the cytosine is changed to a thymine. It then causes this amino acid change, and then you have a downregulation depending on what the level of the polymorphism is. And if you're ever researching It's the RSID that you really want to look for, because it can be confusing, because research can present it like this, they can present it like this, and so it's actually can be quite difficult. And you can see the A129C is an adenine to a cytosine, and then you get the amino acid change, and here's your RSID. You can see they're very similar. So patients say, okay, so what does this mean? What do I, like, okay, I'm homozygous. What might this mean? Well, it might mean that particularly if you have roughly a 60 to 70, and I've actually seen studies say up to 75% loss of function. So your ability to create the active folate is reduced by 75%. That's pretty key, particularly when environmentally you might be exposed to a lot of stress on a daily basis. Stress is the biggest user of methyl groups other than anything. Stress. And how many people are exposed to stress every day? Every one of us. And that can be physical stress, mental stress. So even athletes that are overtraining and overperforming can get a reduction in methyls. And it would be a very interesting exercise to look at our elite athletes like Ian Thorpe, who actually have had depression, to see if they had the MTHFR gene, because I'd really like to see if that makes them susceptible. So stress is a big trigger, and you can often say, people when I was doing all my information nights, they'd say, but I've had this gene my whole life. How come it's only affected me 4 years ago? What was going on 4 years ago? My mum died and I had a miscarriage. There's your trigger. That's stress. And often you've got enough methyls to turn the stress response on, but you don't have enough to turn it off. And I think that really is the key when we're talking about adrenal fatigue. Controversially, I don't think adrenal fatigue exists, because I can tell you, if I get the methyls right with my patients, how can you one day say you have adrenal fatigue and 1 week later you don't? You get the methyls right, adrenal fatigue goes, because all of a sudden their ability to cope with stress has increased 1,000-fold. So if it was real adrenal fatigue, in my book, that could take 6 months to a year. It wouldn't turn around in a week. So those people that come into you and say, I'm adrenally fatigued, be thinking about methylation. So when we have heterozygous, essentially, I'm going to have to try and get this little button right. It's a 30 to 40% loss of function. The A1298C, it's not as big a deal, and I don't tend to really think much of a heterozygous A1298C. Homozygous, 40% loss of function, but these are the two, and given that we're talking about anxiety and depression, these are the two, particularly the homozygous A1298C, that you will see a huge family history of depression. And Andrew Rostenberg is going to be talking about tetrabiopterin on the weekend, which is very relevant. And if you have one of each, it's a 40 to 50% loss of function. So that's essentially 677T. If we were to generalize, most of the medical fraternity would say that confers to an elevation in homocysteine. Not always. Often it does, but not always. So one of the first things you are going, and one of the best things you can do to have a look at methylation capacity is look at homocysteine. We want it to be sitting between 6 and 7, correct? That's the optimal, or sorry, 7 to 8 is the optimal. 6 to 8 we'll live with. But you'll see a lot of your chronically ill people have a very low homocysteine. If you see high, we definitely know that B6 and B12 and trimethylglycine and B6 need to be introduced. But if it's low, why? If it's low, it's because A, methionine is low. B, and often you will see a history of vegetarianism or vegan or horrific gut issues that means they don't have enough hydrochloric acid to cleave the methionine from their meat protein. Or a lot of oxidative stress, so cysteine is literally being stolen from homocysteine to support glutathione production, and I think that's a big part of it. So we've got a lot of factors going on, but it can give us some good clues just looking at homocysteine. And then, as I said, these are the neurotransmitter issues, and they tend to have more problems. So methylation is simply this carbon. A methyl group is a carbon surrounded by 3 hydrogen. And it's this arm that then latches on to the proteins and the enzymes and says, okay, here we go, boys, we're ready. That's why we need it, because it is this arm that goes, right, let's go. So as I said before, it actually helps turn genes on and off. So tumor promoting genes are turned off by methylation. That's why we see a lot of studies that say if you have good amounts of folate, particularly in the colon, we see a good connection there, then it's preventative for colon cancer. When you see studies that say excess folate causes cancer, well, I'd say 10 times out of 10, I've never seen a study that wasn't on folic acid. Never. So it repairs our DNA and RNA, reduces the aging process. So our telomeres are held tightly and bound by methylation. So when they unravel, it's a good indication that we have a problem with our methylation. Detoxifies chemicals and heavy metals. Arsenic is detoxified by a methyl transferase. Arsenic methyl transferase. Most of our heavy metals need methylation. That's why so many kids with autism have MTHFR, have problems with heavy metals, because their detoxification process is being jammed up by the lack of methylation. It helps us process hormones, build immune cells, turns the stress response on and off, provides us with energy. Most of us think of our citric acid cycle at the top of the pile. It's not. It's downstream of our third pathway, which is our CBS pathway. So your chronic fatigue patients, they have a problem with methylation. 100% of them. And you can make huge inroads into your chronic fatigue patients by addressing methylation. Reduces histamine. Histamine N-methyl transferase. It's the enzyme that breaks down histamine. That's why so many patients with histamine issues have allergies. And we're looking at kids more and more. I have a theory, and one day I'm going to prove it in research. It's my mission in life. But I actually have a theory that folic acid supplementation is actually going to be the next smoking. I really feel like we are creating a generation of people who are undermethylated, shutting down the folate pathway, have essentially lower neurotransmitters, increased ADHD, increased autism, more reactions to vaccines, and unfortunately our DNA is being affected. So more miscarriage, more, I mean, if you look at sperm, it has men's sperm and the fertility has reduced by 50% in the last 30 years. 50%. And we know that for the high risk fertility patients, giving 5 milligrams, which is a standard protocol of folic acid, actually reduces the sperm epigenome. It's crazy, yet we're still doing it. It repairs our cell membranes because we need our phospholipids, particularly phosphatidylcholine, and it supports neurotransmitters. And here are some of the conditions, just some, that are attributed to this whole process of donating methyls to methyltransferases and how it's affecting us. Now, you all know you can access these notes, right, online? It should be online. So you should have all got a link. It is? Okay, so the ladies there are saying it is on. Okay, so some of you have it and some don't? Okay, you don't? Oh, is it? Okay. Um, can someone just go out and grab Lisa and we'll just let her know that there's a problem? You got it? Okay, good. And is the Wi-Fi not working in here? Oh, okay. All right. Okay, good. Is everyone okay now? For those of you that don't, just talk to the ladies here and we'll get you connected. Because I can see you taking photos and I just want to make sure that you're all good. Okay, so what affects methylation? So environmentally, a lot. Environmental toxins, pollution, bisphenol A, heavy metals, lead, mercury, arsenic, stress. Stress is at the top of the list for me. Aging, excessive exercise, medications. So anything that reduces your stomach acid, that reduces B12, you got a problem. And for those of you that are staying for the summit, I hope you all are, you're going to learn a lot about B12. But without B12, you're not going to use your methylfolate. Forget it. End of story. There is nothing more important to get the process going than B12. So if you have got people with chronic gut issues and have got vegans and vegetarians, and I have this conversation and I have to be pretty tough, I don't want you to be a vegan and vegetarian. Sorry, but I have a big problem with it. When did you get sick? Invariably, they will say 18 months to 2 years after I became a vegan or a vegetarian. All of the chronically ill people that are vegan and vegetarians, that is the timeline. Why? Probably because they had methylation issues in the first place. Probably because, and what's really interesting, I saw a study that said most vegetarians and vegans start being vegetarian and vegan because they had a problem processing protein. It didn't feel right. Why? Probably because they had a low hydrochloric acid in the first place. So what have they done? Unfortunately, they've just made the problem 100 times worse. Because the less you use the hydrochloric acid, the less you're going to produce it. Vegans and vegetarians don't need it. So what happens? Their B12 plummets and their ability to use their methylfolate goes out the door. They're eating buckets of folate. The folate isn't the problem. They just can't use it. Diet obviously has a big impact, and alcohol. All right, so essentially, now, I did also send you last night a link to the Ben Lynch Pathway Planners. Did you get that email? Sorry? You didn't? Last night? Oh. All right, so I spoke to Ben earlier in the week. So Dr. Lynch has just released these brand new pathway planners that are specifically for patients. So they're simplified and easy. So I would encourage you all to get them to start so you can print them out and go through them. But this is the big picture one. And I know it's hard to see, but we're going to break it down. But essentially, all this occurs inside the cell. So I think that's important to remember. This process is inside every single cell in the body. And essentially, we have our folate pathway here. We have our methionine pathway here, where we create SAMe, and that's donated. SAMe gives off its methyl donor and then converts back to homocysteine that picks up the folate again with the help of B12, and then this cycle progresses. We then have what's called our CBS, or if we include methionine, our transsulfuration pathway. That's this. Homocysteine is sitting here. There are two routes of recycling of homocysteine. One is this way, and one is this way through an enzyme called BHMT. So methionine can get recycled, and homocysteine, and this is quite a dynamic process, but it needs B12 as the linchpin to pick up your folate. Now, the only route of elimination for homocysteine in the body is through this CBS pathway that is B6 dependent. Now, 90% of your methylation patients are going to come in and their problem will be in this part of the pathway to start. So addressing your CBS is usually your first place to start. So here's what I do. One, I put in a B12. I decide what form of B12 my patient needs. Is it methylfolate, methylcobalamin? Is it hydroxycobalamin? Or is it adenosylcobalamin? So there are three forms of B12. Hydroxycobalamin is your precursor to your two actives. Your neurological B12 is methyl B12. Your energy B12 is adenosine B12. Okay? So that's your first thought. What form of B12 am I going to give my patient? And I don't care what their level of B12 is, if they have signs and symptoms of any neurological issues or inability, and don't forget, this enzyme is inhibited by yeast, by mold, any LPS. So inhibition of this enzyme is very easy to happen if someone is chronically ill. So I always start with B12. It's the first thing, because I assume with the gut and mold and everything else that's going on that there's a problem. Then I put cofactors in place. B1, 2, 3, 5, 6, put those in place, and then I decide what I'm going to do. So my line of questioning in my first appointment is going to be around here. And we'll learn a lot more about that when we get into the CBS. So let's look at folate first. So remember we said this is in the cell, and we have our, if I just quickly go back to this, you can see you have an SLC transporter, you have folate receptor 2 and folate receptor 1. Folate receptor 2 is the main enzyme that pulls folate from the extracellular environment to the intracellular environment. Now, folate receptor 2 is actually folic acid prefers to bind to folate receptor 2. So what does that mean? Well, we know that dihydrofolate reductase, this first enzyme that goes, okay, I've got it, I'm going to handball it down the pathway. This first enzyme is inhibited by 200 to 300 micrograms of folic acid. Now, the guesstimation from the very little research that exists is that most people, if they're taking a multivitamin with folic acid in it, are getting 1,000 odd micrograms because it's in breakfast cereal, it's in our bread, it's in almost every packaged good, it's in almost every drink that's in a tin or a can. We're getting a lot of it, and we're getting it from a lot of different areas. So if everybody's getting roughly 1,000 micrograms, if they're on the standard American, standard Australian diet, this poor old enzyme goes, well, sorry, I'm overloaded, I can't work. So what does that mean? It's actually shutting down your ability to metabolize these really important folates here. Because tetrahydrofolate, you can see, not only converts to 10-formyl and 5,10-methanol and then down to your 5-methyl, but it's also crucially important for recycling. So, and here is 5-formyl is our phelinic. So you can see that phelinic and methyl don't actually need to go through this pathway. So folic acid as a form of folate is actually not great because we can't use it. We can't use it, and we've got the potential for it to increase, and you can see this UMFA here, unmetabolized folic acid. There's a little bit of research, so see here, unmetabolized folic acid. There is a bit of research that suggests this is the problem when we get the excess. This is the potentially dangerous folate that is causing issues. We don't have any direct research, but is this actually the folate that they're looking at when they're looking at the cancer trials? Is this the folate they're looking at in a study last year where they said excess folate confers for autism? I think it is, but we don't have any proof 100%, and we're probably never going to get it. Because how would you do a clinical study to give people folate to see if they get cancer, folic acid to see if they get cancer or autism? No one's ever going to approve that. So we don't want to be using folic acid. And so clinically, if you did nothing else, so let's say someone comes in, they're homozygous MTHFR, and you're thinking, oh, I'm just going to see what's going on with their methylation. Do nothing else, nothing, but take them off folic acid and ask them to come back in 2 weeks. And I bet you they feel better. And these are also the people that say, I could never take a B vitamin because I feel sick. Most people who are homozygous MTHFR will say, I've never taken B vitamins because I feel sick when I do. But what they're forgetting is that they're getting it in all their food. So we need to make a concerted effort, I think, to get them off the folic acid because it is disrupting. And I can tell you categorically, from a fertility point of view, 100%. If you use the active folates, you will take away the infertility issues. 100%. So we've got to be very mindful of this process. So tetrahydrofolate is key, and it will recycle, it will regenerate, because this is dynamic, it's not static. And so here you can see your 5-methyl at the very end, and our cofactor for MTHFR is B2, riboflavin. So it's important when something is down-regulated that we support with the cofactor, right? To give it a chance to improve its working capacity. And as I said then, we create the methylfolate with the help of B12. We then create methionine, SAM. SAM gives off its methyls. It then becomes SOR, and then we get homocysteine. Okay, so that's just the structure to show you the different folates. So folic, man-made supplemental, has no biological activity unless the body can use it. Folinic, you saw where folinic was, but the thing about folinic is, and particularly in fertility, we see that a lot of people have an MTHFS polymorphism. And that essentially is the enzyme that takes folinic and breaks it down to 5,10-methenyl tetrahydrofolate. So if you've got a polymorphism in MTHFS and your ability to break down folinic isn't so good, then you're not going to be wanting to give folinic. And again, this is where it's important to know the pathways, because then you can understand what you might be giving and when. But we do not want to be giving folic. Okay, so here's just this study on folic. It says the extremely slow and variable activity of dihydrofolate reductase in human liver and its implications for folic acid intake. So it says, we observed that folic acid behaves as a non-competitive inhibitor of dihydrofolate reductase at low concentrations. Then it goes on to say that both folates compete for the same enzymes. And if we look at this, it says the natural killer cells have been reported to be decreased when you have an increased unmetabolized folic acid. So are we actually affecting immune function by having this elevation in folic acid? Some studies would suggest that we do. And as we know, folic acid causes a masking of B12 deficiency, but methylfolate doesn't. Folinic doesn't. It does not mask a B12 deficiency. Folic acid does. So we do need to understand more about it. And here's this study that I was telling you, in that it says, contrary to expectations, high-dose folic acid supplementation resulted in a global loss of methylation across the sperm epigenome. Loss of methylation was more prominent in the sperm of individuals with MTHFR homozygous, but it still happened in people with no MTHFR polymorphisms. So what the heck are we doing? This is the standard protocol for high-risk couples. 5 milligrams of folic acid. This one, persistent circulating unmetabolized folic acid. So this was a study done in Ireland, I think, and it says, in conclusion, the majority of the population in Ireland are now exposed to the liberal voluntary fortification regime. It appears to have circulating unmetabolized folic acid as measured in plasma from non-fasting subjects and fasting women who had undergone caesarean section. The extra folic acid to which consumers will be exposed if mandatory folic acid fortification goes ahead, and it did, will undoubtedly increase these levels. The consequences of this are unknown, but we should be concerned. Is anyone actually looking at this? Very few people. But there's enough people going back to, I think this was a study in the early 2000s, so we've known for a bloody long time that this is potentially an issue. Yet everyone's burying their head in the sand. And I would really hate to think that this is because Big Pharma loves this product. It's in everything. Everything. So is this a political thing? I had someone was telling me yesterday that, you know, they actually it was you were saying, Dr. Go, that he was talking to the fertility clinics and they say MTHFR doesn't matter. Why would we be looking at that? That's ridiculous. Oh, you're just one of those funny MTHFR doctors. Doesn't mean anything. Well, clearly it does. So, folic acid fortification and public health. So this was a study done by Sweeney. Our findings suggest that persons exposed to the current US fortification program of 100 micrograms seem to be okay. However, increasing the level to 400 on the other hand is likely to lead to unmetabolized folic acid. Every single supplement in the US, the minimum folic acid is 800 micrograms. 800, double that they're saying is increasing folic acid, unmetabolized folic acid. Folinic. So it is, again, it is an active folate, but again, we just have to be a little bit careful because there are some people that do have trouble processing folinic. So here, if we look again, here's our MTHFS. So that's where that enzyme sits. So it is really crucial to be helping to support that and making sure. And magnesium is the cofactor for that. And so it will help recycle our MTHFS to the 5,10 methanol. And then we have our methyl. And you can see we were talking about methionine synthase. So it is inhibited by aluminium, cadmium, mercury, lead, an increase in nitric oxide, an increase in reactive oxygen species, TNF alpha, like low B12, low glutathione. How many of our patients does that apply to? So B12 is crucial. The first thing you've got to do is give B12. Do you get that message? You're going to get it over the weekend. You're going to walk out of here with B12 stamped on your forehead. All right, and then we've got our active. And of course, if someone has an MTHFR polymorphism and it's only working to 25% capacity, like our homozygous, then what does that mean? Well, it means that all of this can be happening and recycling, but unfortunately, if we've got this working at 25% capacity, we can give B2, we can give niacin, NAD to help it, but we are better off to give this if we can. But we don't give it to start. And it's usually the last thing that I do. B12, cofactors, address CBS. When I've addressed CBS and the problems, and the reason why people react to methylfolate isn't because they can't have it. Oh yeah, they can't have it. You've got this polymorphism, they can't have it. Rubbish. 90% of the time it's because that enzyme is inhibited. So if you are giving methylfolate and this is blocked, what's going to happen? They're going to feel pretty crappy. They can be depressed, they can be anxious, they can get rashes, they can get, a million different things. But we have to make sure that we unblock this. All right, so we've just learned that that's where our folate pathway is. Here we're talking about methionine synthase. You can see acetaldehyde from yeast will inhibit it. Cofactor is zinc. So how many of our patients with gut problems have low zinc? So 1, they've got a problem with hydrochloric acid. 2, it means they've got a problem with B12. 3, because of the hydrochloric acid and the gut stuff, they've got low zinc. So another reason why methionine synthase suffers. So methionine synthase picks up the methyl, and here we go into this pathway. Right, so when we're talking about folate, remember I said there's going to be certain questions that you want to ask which will make you think of the folate pathway. So here they are. Do you have a family history of allergy? Why? Because histamine N-methyltransferase needs methyls. Do you have a history of multiple miscarriage? Any depression, anxiety, pyroluria, addiction, chronic fatigue, family history of stroke, heart attack, particularly deep vein thrombosis, high cholesterol, hypertension, and memory issues. Family history of cancer, especially colon cancer, because we know that folate is semi-protective. Um, Women who say they've never been able to tolerate the oral contraceptive pill. That's a big clue. People who say they've never been able to tolerate any B vitamins. That's a huge clue. Someone who's never been able to lose weight, because fat metabolism really, really important in our methylation cycle. Cholesterol elevated, cholesterol low gives us good clues. Low fat soluble vitamins. Why? Because we need a really good cellular membrane, which is fat, which is made of phosphatidylethanolamine, phosphatidylcholine, and phosphatidylserine. So our three fats determine how much of your fat soluble nutrients get into the cell, A, D, E, and K. So think about that with someone with a chronic vitamin D. Yes, they might have a vitamin D receptor issue. However, it's more likely they have a lack of phosphatidylcholine because the enzyme PEMT, phosphatidylethanolamine methyl transferase, takes phosphatidylethanolamine, converts it to phosphatidylcholine. That relies on methyls. And memory issues. So if you have someone that says, oh, I'm losing my mind, I just can't remember anything. I can't remember where I left the car keys. I can't remember where I leave my car in a car park. I think I'm losing my mind. If there's no family history of Alzheimer's or anything like that where you need to be, well, even then I would say, well, okay, it's probably a phosphatidylcholine issue. I'll give you an example. I was at probably about 7 years ago, I was at a party with my husband and I'm standing with a group of people and I went to introduce him and I couldn't remember his name. And I thought, oh my God, I'm losing it. I'm going to end up with dementia. And I thought, what the hell? So I did my 23andMe. This is when I was, sort of starting out. And I realized that I have MTHFD1 and PEMT polymorphisms. So for me to be able to make phosphatidylcholine, it's actually quite difficult. So I started taking phosphatidylcholine and CDP choline. In fact, I take it every time I have to get up here because it really helps me. And I don't have an issue anymore. Like, hello, all this biochemistry in this head, it just comes out. But I don't think it would. I'd be sitting here stuttering and going over trying to think of words to say if I wasn't supporting it. So that's a big clue. And I say to patients where I really think that it is a methylation issue, you're not getting Alzheimer's. You are not getting dementia. The most important enzyme that converts your brain fat needs methyls and you don't have enough. That's actually very comforting. And you know what? You will have them come back in 6 months. It's not going to happen overnight. But in 6 months, they will come back and go, I don't have a problem anymore. How good is that? Because they just needed some phosphatidylcholine. And how did you know that? Because you can look at their genetic susceptibility. This is where this is really powerful stuff. And it does change lives. So if we as naturopaths or nutritionists, someone came in and said, I have a problem with my memory, you'd give them ginkgo, right? Would that work? Not really, because that wasn't the problem. And this is where it's different. You can actually have a targeted approach. All right, so some of the clues that someone might have an MTHFR polymorphism. Elevated red cell folate. Serum B12 under 358. Under 358. What is our reference range starting at? 154 picomoles. Hello? It's insane. So most of our patients don't have good levels of B12. Chronic low white cell count neutrophils and lymphocytes. Remember you heard that it helps with immune function. So I look at that and I say B12 and folate, probably a problem if I see low white cell count. Increased mean corpuscular volume. Yep. Yes. Can we leave it till later? Remind me, okay? Because it is a good question and I will definitely, I do need to address that. Okay, so mean corpuscular volume, we want it under 90. Anything above, think B12 folate is a problem. Increased red cell distribution width, anything over 13%, think B12 and folate. Low hemoglobin, elevated homocysteine, increased creatinine kinase, and low hemoglobin. So when I'm seeing these, I'm thinking, amongst other things, but really importantly, okay, I know I've got a problem with B12 and folate. Elevated GGT. Why? Because GGT, if it's elevated, is a really good indication of fatty liver. And when you have recurrent SIBO and fatty liver and issues with gallbladder, then we know we've got major deficiencies in these cycles. Taurine, definitely through that CBS pathway, is affected. But phosphatidylcholine, if you give someone phosphatidylcholine with an elevated GGT, it will come down. It's not really, well, it is to do with the liver, but it's not because they have a problem with drinking. It's because they have a lack of phosphatidylcholine. Fat-soluble vitamins A, D, E, and K. Okay, remember we said again, phosphatidylcholine is needed to get them into the cell. Fat metabolism, again, we need phosphatidylcholine. We need methylation for fat metabolism. I've seen people lose 13, 16 kilos by doing nothing more than changing the form of folate they're using. Elevated blood pressure and low blood pressure. Well, okay, blood pressure can give you some good clues. Our major gas emitters that regulate blood pressure are nitric oxide, hydrogen sulfide, and carbon monoxide. Now, it's the hydrogen sulfide and nitric oxide that get disturbed when we've got methylation issues. More complicated than that, but basically that's what's happening. So if we've got a lot of nitric oxide and hydrogen sulfide, we've got a very wide blood vessel. Therefore, we have low blood pressure. If we have a very constricted blood vessel, we have not enough nitric oxide for vasodilation and hydrogen sulfide. Nitric oxide is made in our tetrabiopterin pathway, and you're going to hear about that over the weekend. So I would tend to say those people with blood pressure that's low, I go to hydroxycobalamin, because high-dose hydroxycobalamin will mop up nitric oxide. If someone has high blood pressure, I want to encourage vasodilation, so I'm more likely to use methylcobalamin and maybe look at arginine and whatever else I can do to improve nitric oxide. So blood pressure can give you clues, and thyroid function. Why? Because T4 helps our B2, that is the cofactor for MTHFR. So there is an integral relationship with thyroid function. All right, so methionine. So here's our methionine cycle, and we're going to look at the various elements within this. So here's SAM, just for those of you that don't remember, here's SAM. So methionine synthase picks up the folate with the help of zinc and B12, because MTRR is the major recycling. So this inner circle is how we create and metabolize our B12s. And you can see the cofactors for MTRR, SAM, B2 and B3. That's why it's important we get our cofactors in. 25 milligrams of B2 is really essential. And so you are going to recycle your Bs, which will get this circle going to pick up the folate methionine. Methionine, with the help of this MAT gene, which is ATP and magnesium dependent, Again, a very important enzyme because it is helping to make SAM. But you can see here it's inhibited by nitric oxide, lipopolysaccharides, and all sorts of infections and inflammation. So the two key enzymes that we need to make SAM can be inhibited if there's problems with lipopolysaccharides, infections, etc. So we have to deal with those first before we start putting in methylfolate, because you're just going to kick a pathway that isn't coping particularly well. So SAM then says, thank you, I'll give off all my methyls to the methyltransferases, and in the process it makes SAW. SAW then helps make adenosine, and we're going to learn about adenosine over the weekend with the help of this adenosine homocysteine hydroxylase enzyme, and we then make homocysteine again, and then the whole process picks up. So SAM is known as a whole lot of different things, but in the research, mostly Adomet. That's mostly what you're going to see SAM written as in the research. It has to be, methionine must be activated through the formation of SAM, and it's basically what you need to know is it's our universal methyl donor. And every methyltransferase in the body has to have SAM. So some methionine metabolism disorder issues can be any of these. And I find that so many of our chronically ill patients have low methionine. And as I said before, you know, when you're nervous about giving methyls or you see that homocysteine is low, giving methionine can actually be quite good because it is going to help with SAM. But if they have a massive sulfur sensitivity, you're not going to give the methionine until such time that you've cleared that sulfur sensitivity. And we'll talk about that when we talk about CBS. So, and meat protein is where we get methionine. You don't get it from vegetables. So again, vegetarian, vegan patients, or just patients that don't eat any good quality meat protein are going to be affected with a lower methionine. Hydrochloric acid and gut issues, they're going to be predisposed to having low methionine because you need good amounts of hydrochloric acid to cleave that methionine from the meat protein. So if you see high methionine with low homocysteine, this could be an elevation due to an inhibition of those two enzymes that I showed you. But low methionine, more likely to be poor quality protein, detoxification issues, inability to sustain methionine levels during that overnight fasting. And so we may want to give them an amino acid mix with some methionine in it. So homocysteine, as I said, it can be a really good marker for us to get started. And the nutrients that we need for homocysteine are all of these here. So you can see if we want to support homocysteine, we need to be making sure that we've got our folate, our zinc, our B12, zinc again, but also trimethylglycine helps this pathway, and magnesium, and obviously B6. This is the B6 dependent pathway. And these two just really show you, I think the next one's probably better, to show you that when you see reduced homocysteine, the cysteine, as I said before, is stolen to support this cystathione creation of cysteine, because the body will protect glutathione at all cost. And so cysteine is needed for glutathione. So we often see low homocysteine when there's a big battle with glutathione and high oxidative stress. So CBS, I think we have a tendency to go in too hard, too fast with B6. And I see a lot of people who are on pyrrole formulas for long periods of time. And what is the high dose pyridoxine and P5P going to do? Bottom out homocysteine. I've seen kids with homocysteine levels of 2 because they're on these high dose. And remember I said the only elimination route for homocysteine is down this pathway with the help of B6. You don't want to bottom out homocysteine. I really believe that I don't check for pyrols anymore because I seriously believe if you fix this part of the pathway, pyrols go. They just come right down. So my strategy is always to go in with 15 milligrams of P5P because P5P stimulates this pathway a lot less than pyridoxine. Pyridoxine will stimulate it much more. And when you think of some of these pyrrole formulas, you've got people who are on 150 milligrams of pyridoxine and then probably 100 of P5P. So it's stimulating the pathways too quickly. Now, when you consider that most of your sick patients, their problem is with this part of the pathway. So why would you kick someone hard to stimulate a pathway that they're having problems with? It doesn't make a lot of sense. So the key things that you want to be doing after you've done your B12 and your cofactors is you're going to be asking questions about this pathway. So 1, it's where we detoxify sulfur. Okay, so sulfur is our biggest issue, I think, in this part of the pathway. You'll see SUOX gene. I've never seen anyone ever with a homozygous SUOX gene problem. Never. They do in the US, but obviously different populations have different issues. But so analysing whether or not someone has a sulfur problem, and the number one question you're going to ask, how do you cope with sulfur-based foods? Onion, garlic, eggs, broccoli, cauliflower. Do you eat them? Oh, God, no. I've been on a FODMAP diet for 15 years. Is that a problem? Yeah, it's a big problem. We need sulfur. Sulfur is essential for our joints. It's essential for our hormones. It's essential for our neurotransmitters. We don't want to deplete sulfur. Maximum you deplete sulfur in the diet is 3 weeks. Max. I had a patient of mine come in many years ago and she said, I've been on a FODMAP for 15 years. I'm not going to go off the diet. You are not going to talk me out of it. There's no way you're going to talk me out of it. I'm going to stay on this diet. And I said, all right, you have one or two choices. You either take my molybdenum and you do what I tell you to do, or you go out the door right now. Because I'm not going to muck around. Because I'm telling you, you don't have a FODMAP issue. You've got a sulfur issue, and the problem is you're not detoxifying sulfur. If I give you this molybdenum, in 2 weeks' time, you'll be able to eat cauliflower, broccoli. Bullshit, she said. Bullshit. No way. She rang me 2 weeks later and she said, oh my God. I have seen 400 people in 15 years and you fixed my problem in literally 2 weeks. I said, yes, I told you that, didn't I? So sulfur, a lot of people have a sulfur sensitivity. I did. I love molybdenum. It's the best thing that ever happened to me because it means I can have a glass of wine and not have a migraine within 10 seconds of having the first mouthful. I did not drink wine for 10 years, not one sip, because I was terrified of the migraine that was going to happen. And a sulfur headache and a histamine headache hits you there. There is nothing you can take to make it go away, except molybdenum. So molybdenum detoxifies sulfur. So other than asking them, do you have a problem with sulfur-based foods? You're also going to say, do you have diarrhea? because sulfur can definitely cause loose stools. I have patients who have one egg and they're literally on the toilet within 30 seconds of finishing that meal. Breathlessness. So sulfur too high or too low can aggravate asthma. You know, a lot of asthmatics can't go anywhere near sulfur dioxide because it actually brings on their asthma attack. That's why, because they're not detoxifying sulfur. Molybdenum will help them do that. Now, they don't have to be on molybdenum for their whole lives, but when they feel like the sulfur, so the process with sulfur is probably for another day, but it's great to see people's sulfur come back into where it needs to be, because then you can give them glutathione, you can give them methionine, you can give them sulfur-based amino acids that can really help them, particularly if they've got glutathione deletion genes. So sulfur is one of the things you're going to be looking at. The other is taurine. So you can see that taurine is made as part of this pathway. Now, when Amy Yasko first started lecturing about methylation about 10 years ago, she said, this is an upregulation pathway categorically, and you never give taurine because it's always too high. But her audience, her patient profile was 100% autistic children, and they do have a bit of a different profile with this. But on the whole, you will find that most people have low taurine, particularly those that are constipated. 100% of your patients that have constipation have low taurine. You give them taurine to support biosynthesis and they will start going to the toilet every day. Taurine is an inhibitory neurotransmitter. It's calming. It's like GABA. It's like glycine. We need it to calm our patients. So I'll typically do a mix of magnesium, vitamin C, and taurine, and a little bit of guar gum at night to help them go to the toilet. And it's an awesome mix. So taurine, biosynthesis, feeling sick, get nausea a lot when I eat, can't go to the toilet, stressed out, taurine is great. But it is an important part of this pathway. What's also made in this pathway is glutathione. So important. It's our major detoxifier in the whole body. We already know that patients with MTHFR polymorphisms have a problem with detoxification. So that's an issue. So it is being affected here, and then we've got other key enzymes like superoxide dismutase. But remember I was talking about our citric acid cycle? It's down here, right? So we need homocysteine to be converted to cystathionine, to be converted to alpha-ketobutyrate, to methylmalonyl-CoA, to succinyl-CoA to kickstart our citric acid cycle. Here's adenosine. Your energy B12 kicks in here. So this is why patients with B12, and we were talking about our actives, one active is adenosine, one active is methyl, and they work on different parts of the pathway. But adenosine is the cofactor for this methylmalonyl-CoA mutase gene that kick-starts and creates succinyl-CoA. So that's why so many of your methylation patients come with chronic fatigue. So, CBS issues, what are you going to look for? Low zinc, high copper, low B6, potentially. I also look at oxalates. So if you, we're about to release last year's summit recordings, and we talked a lot about oxalates in that. So if you want to, you can, and we've got lots of webinars on oxalates on our website. And I should say, after the weekend, if you want to go further, you should look at joining our practitioner membership group. So it's on our mthfrgenesupport.com. It's on our US site. and you can join, and we've got a lot of our members here, which is awesome, and it's a great lot of like-minded practitioners all working together, and we do case studies and we talk about all these issues. So sleep, and one of the things I didn't talk about was serine. And if we go back, oops, here's serine here. So again, B6 dependent, but serine is created here. So we use our serine. So this is part of the problem, is phosphatidylserine is actually quite low with a lot of our patients. Sleep issues, so serine. Oxidative stress, an issue. Gut. Ammonia. So this is the other question that we would ask. Ammonia. A natural process of us eating meat protein is that we create ammonia that then has to be detoxified through the CBS pathway and nitric oxide synthase pathway. Now you're going to hear a lot more about nitric oxide synthase on the weekend. But if someone can't detoxify ammonia, it will affect that CBS pathway. It'll probably give them headaches. It'll probably give them brain fog. It'll probably give them stomach upsets. So evaluating ammonia can also be, and I think the extreme of ammonia issues is that patient that sits in front of you and you ask them a question, but they actually have no way of answering you. They look at you in a stunned stupor, and I'm saying that in the nicest sense of the word, and they just can't answer you. That's what I call an ammonia patient. They're in a stunned stupor because ammonia essentially will shut down brain function. Gut issues, high homocysteine or low homocysteine, and CBS mutations, obviously we evaluate that sulfur. Diet, so histamine and oxalates, key, absolute key. And histamine and oxalates will usually be one or other of the first diets I put them on. And on our website, we have webinars on both of those. Pyrols. So again, I'm very cautious of pyrrole formulas. I don't tend to give them anymore. I will definitely give zinc, and I'll give a little bit, 15 milligrams of B6, and I might come in a bit later and give a little bit more B6, but I'm always monitoring what's going on with glutathione and homocysteine. We definitely want to balance copper and zinc, and I'm so excited that we've got Stephanie Fryer-Williams talking about this whole zinc and copper debate, because I just have a feeling we're missing something big with copper. We need copper. We really need it. We need it for our neurotransmitters. We need it for histamine breakdown. Yet all we seem to be doing is decreasing it. So there's something we're missing. I haven't found out what it is yet, but I'll let you know when I do. But there is something that we're missing with copper. So when I've got copper and zinc balanced, I always give copper on a 8:1 zinc to copper ratio. I never just give zinc anymore. I will give copper when I've got them balanced, unless they're on the oral contraceptive pill, where we know that that's going to increase the copper anyway. And molybdenum also helps with that copper, and I do think that's got a big part, because that's a triumvirate in terms of copper, zinc, molybdenum. They work together in synergy. So I'm wondering whether we're seeing more of a molybdenum deficiency, which is quite likely, that is upsetting the copper-zinc balance. Because when you put in the molybdenum, it does seem to help with this copper-zinc balance. Urea cycles, so this is what we were talking about. It is integrally linked in, and these are homozygous with the nitric oxide synthase SNPs seem to be the ones that struggle with ammonia. So these are the patients I might actually look at reducing their protein levels, because I'm not sure that they're processing it particularly well, and I'll give them some amino acids to help basically clear that protein and ammonia. So as I said, comatose presentation, they can't answer the question. They actually have to think. I had this 18-year-old boy came to see me many years ago, and he was with his mum, and he did have a lot of neurological issues. And I asked him how he was, and he didn't say anything. And I thought, okay. And I said, well, okay, well, why don't we talk about how you're feeling at the moment? And I kid you not, he sat there for 2.5 minutes, and I held firm. I didn't say anything, but that's a long time. For 2.5 minutes, he just looked at me and he said nothing. And then 2.5 minutes later, he answered me. And I thought, wow. Now, he's moved overseas, so I don't see him very often. How his personality has changed. He's a little gas bagger. And it was so amazing. But I knew straight away, my God, we've got a real ammonia problem. And we did fix, the first thing I gave him was an ammonia formula. And he literally started talking that the next appointment, it was such a much better appointment. It took a while for him to get back to where I wanted him to be, a few months. But that first appointment was excruciating. But I just sat there and I waited and I let him answer. So lack of energy because ammonia depletes cells of ATP, and as I said before, gut dysfunction. So chronic fatigue, headaches, irritability, diarrhea or nausea, lack of concentration, mental confusion, intellectual impairment, intolerance of foods, particularly protein, ataxia, stupor, low blood urea nitrogen, so low BUN, and activation of NMDA receptors in the brain. And that's one of the biggest issues because these NMDA receptors are creating excitotoxicity through the elevation of glutamate and the problem with the non-conversion of glutamate to GABA. So you get excitotoxicity and usually an elevation in quinolinic acid. Taurine deficiency, we talked about that, but obviously anything to do with fats, epilepsy, anxiety, seizures, because it acts with glycine as an inhibitory neurotransmitter. Tinnitus, because it increases the inhibitory tone and decreases the noise in the auditory pathway. Big drinkers, well, big drinkers are going to be affected by not only taurine, but also their B vitamins, particularly thiamine. Inflammation, fat metabolism, dysregulation of calcium and potassium. And don't think CBS is high taurine as of Yasko. There is no evidence to support the fact that this is an up regulation. So when you're seeing that CBS polymorphism, don't think, oh my goodness, it's an up regulation, everything's going to be fast. Think, I need to ask the questions around taurine deficiency, ammonia problems, hydrogen sulfide, sulfur issues. That's what you're thinking. What is happening with zinc? What is happening with copper? What is happening with molybdenum? That's what you're thinking when you're thinking about CBS++. Glutathione we've spoken about. We know how important it is, and particularly for our intracellular. Oh, we've got a break. All right, let's ask questions because I've still got, is that right? I've still got time. Yeah. Yes. Mm-hmm. Okay, so the question is when you've got low active B12, holotranscobalamin, and low serum B12, would you consider giving them a combination of B12s? Yeah, that's the question. Yeah, quite possibly. Yeah, adenosine and methyl. Yeah, I probably would. MMA, when you're seeing an elevation in MMA, that's definitely adenosine. Don't bother giving methyl. That's adenosine when you're seeing an elevation in MMA. because it's that methylmalonyl-CoA mutase is not working, and you saw before the cofactor was adenosine. Okay, so you could definitely give, and I do give combinations of B12 all the time. And if there's chronic fatigue and an elevation in MMA, absolutely, I will definitely give it. I just then will decide, do I want to give hydroxy or methyl? My preference is always to give methyl, but if it's a low, I had recently had a POTS patient, and she was on, poor girl, she's young, in her late 20s, and she's on 5 different medications. And this is where it's crazy. If someone is fainting all the time, they can't get up and they can't sit down without getting dizzy and nearly passing out, wouldn't you think that you would go, well, what's going on with vasodilation, right? So the POTS medication fixed it to some degree, but not enough. But literally 2 weeks of high-dose hydroxycobalamin injections, and she was off her POTS medication. She has not had a dizzy spell for 8 months. You've got to think, and this is what I really want to encourage you to do, take the labels off. It doesn't matter what someone is coming in with. It doesn't matter. Don't think about they've got diabetes, they've got POTS, they've got this. Doesn't matter one iota. Think of what is going on with the biochemistry. And when you start thinking like that, nothing will daunt you when they come in your door. I get excited when I've got a really complicated case. I think, oh my God, I'm going to get my brain going. And I go back to the biochemistry books more times than I can tell you, because everything doesn't work exactly the way you might want it to. And you're really going to have to think, well, okay, I gave that. Why on earth would that happen? And if you've got like-minded practitioners that you can talk to about it, it really helps. So I was in Chicago about 3 weeks ago and was speaking to Dr. Pratt Hyatt from Great Plains, who's going to be talking to you over the weekend. And I said to him, I've just got this really weird thing going on with one of my patients. And I think I know what's going on, but you're my biochemical geek friend. Can you see if my theory is right? And every time she went and drank alcohol, because she's got a glutathione deletion gene, she takes a little bit of glutathione. So it really helps her detoxify that alcohol. Not that she drinks a lot, just 1 or 2 glasses, but she was getting headaches and things and feeling quite groggy and hungover just from 1 or 2 glasses. So I said to her, take a bit of glutathione before you go out and have a drink and when you come home. And so she did. But then she got up through the night and she couldn't urinate. Her bladder was busting, but physically it didn't work. Weird, right? So what we thought, well, what my theory was, is that the histamine from the wine was creating the inflammation, and the glutathione was helping detoxify the alcohol and the what else was she taking? The glutathione was helping with the histamine, but it was too fast, too quickly. And so she was getting inflammation of the urethra, and it was causing too fast a shunting of that histamine down that pathway. And as soon as I said back it off, and instead of taking a full teaspoon, take a quarter of a teaspoon, but more regularly every couple of hours, it went away. So again, think about what is going on biochemically. That's what we need to do. Don't ever assume because you've been given a letter from a doctor or they've come in with a diagnosis that that's where you should go. I never go that way. My POTS girl, she has POTS, she's on OCP, she's on antidepressants, she's on everything. I just put it all aside and I said, okay, I don't really care what you've been told you've got, just tell me all your symptoms. What is it that you're struggling with? Well, the most important thing is that I keep fainting every time I get up. Well, that sounds like the first thing we need to start with. She's got a lot going on, mind you, a hell of a lot. But what's the most important thing we have to stop her doing? Fainting every time she gets up. So we fixed that in 2 weeks. So then I went on to the next thing, terrible gut. So you work in processes of what is the most important thing that you need to address. And it doesn't need to be tricky. And you'll see from the case studies that we really pull apart on the weekend that I don't really do anything weird and wonderful, but I do really take notice of the biochemistry and the genetic susceptibility, because that tells me what I need to do. So any more questions? We had a question. Let me answer so ask the question again about the B12. Oh, yes. Okay. So we know that serum B12 isn't the greatest marker on the planet, right? But when we look at the signs and symptoms, so I think that when you're looking at the holotranscobalamin, it's more a reflection of adenosine. But when you're looking at serum, it's more a reflection of methyl. But I would always go on signs and symptoms. I had, okay, proton pump inhibitors, right? If I have someone on that, my first aim in life is to get them off it, number one. And I'll use a protocol, and sometimes it will take me 6 or 8 months to get them off fully. I do it slowly, but it's the first thing I have to do because we're affecting B12 significantly. So I had this elderly gentleman who was incredibly ill come to see me, and he had to be physically brought in by his wife. He could hardly walk. He had been on, amongst like 50 million other drugs, he'd been on proton pump inhibitors for 30 years. And when I looked at his serum B12, it was 55. And I thought, well, no wonder this poor guy can't walk. I mean, he had severe ataxia. And if when sometimes you will look at patients, at the time, I didn't have his holotranscobalamin because he just came in with the bloods that the doctor had sent with him. But the doctor looked at that B12 and didn't make any comment. No comment whatsoever. So I do often see holotranscobalamin, and I've actually looked at the research to find out, can I categorically say that holotranscobalamin is 100% adenosine? No, I can't. I can't from the research say that that's 100%. So my theory is it's probably a combination, but it doesn't make sense that someone would have a really low serum and a fine holotranscobalamin and an okay MMA together. And that's often the pattern I see. So if MMA is elevated, it means that, if MMA is fine and holotranscobalamin is fine, that sort of fits my theory that we're looking more at adenosine when we're looking at holotranscobalamin. The question is okay, let me see if I can get the pathway up. We'll just go back to the last one. Okay, so this MAT really pushes that SAM, right, to give its methyltransferases off. And so if you've got a block in MAT, then that will cause SAM to not go in that direction. Also, SAW is a big determinant of what happens with SAM, because if SAW is elevated, it inhibits all methyltransferases. So we're going to learn a lot about that on the weekend when we talk about adenosine. But an elevation in SOR will cause an elevation in adenosine, an elevation in homocysteine, which shuts off methyltransferases. It activates it. So because it's the cofactor. So the question was, what does the methyl actually do? So when you have a look at what's on here that's a methyltransferase, I don't think we've got anything that is, but when you see COMT, C-O-M-T, the cofactor is SAM. So SAM drives that enzyme movement. It's the same as zinc. Yeah, so zinc is the cofactor for methionine synthase. It drives that enzyme better. Same as B2 is the cofactor for MTHFR. So it drives that activity. It helps that activity. So SAM drives the activity of the methyltransferases. Mm. Yeah, ask me you next year. Why? Why does it drive it? Because that's its job. Like, why does zinc make this work better? Because it's the cofactor. I don't know that I could even research a better answer than that. So you've got to improve the folate. Yep. Well, it depends. Okay, so the question is if you've got low B6, low folate, low B12, particularly 9, that's a very low folate, then what would you, oh, we've got microphone, have we? Oh, awesome, sorry. You're next. So if we've got all of those low and you give B12 and the folate's utilized and it goes lower, what do you do? Well, the first thing, I mean, particularly if you've got CBS stuff going on, then you would fix the CBS stuff, get them to eat as many good leafy greens as you could. And if there's no neurological damage or anxiety or depression, I'd go in a week later with your folate, but I'd go in at 100 micrograms. So I never go more than 100 micrograms at a time. So I say, take with your B12 and your cofactors 100 micrograms of methylfolate. Go for a week, see how you go. If you're all right, second week, I want you to take half. I want you to take 200 micrograms. See how you go. If you're fine, 3 and 4. And then you see. And if they're homozygous, I'd go up again. And I'd do the same process until they come to a point where they go, yep, I'm good. I'm feeling really great. And if you go slowly, you're going to mitigate some of those side effects that you get. In the US, they go 800, 1,000, day one, bang. And all these doctors are going, oh my God, no wonder I'm getting so many side effects. So I go slow and I'm not afraid to push it sometimes to 15 milligrams, depending on what's going on. Yes, PEMT converts phosphatidylethanolamine to phosphatidylcholine, and SHMT uses your serine. Okay, now with the mic. Oh, is it on? Is it on?
Hello? Can you hear me? Um,
Not really. Can we turn it up, please?
Hello, testing.
Yep, that's
There we
perfect.
go. My question is around the B12 injection. What form of B12 is in the injection that's standard given by doctors when they see it?
I compound. So I compound subcutaneous B12 injections, and I do it myself. I'm sick and tired of referring people back to GPs that say, no, I won't do it. So I do it myself.
But what form
Any form.
of B12 is in the standard injection?
Oh, hydroxycobalamin is the stock standard B12 that
Okay.
the doctors will give.
Okay.
Yeah.
Thank you.
Yeah, sorry.
But so you're saying that doctors won't often give
No,
the IV?
you've got to battle every second of every day.
I'm finding that they're okay to give one.
Yeah,
It's not the three.
one 1,000 a month. I give, that's right, George, isn't it? Yeah, that's an intramuscular. But I'm giving subcutaneous, so anywhere from 2 to 4,000 a day. Big bloody difference.
So who administers that then?
They do. It's awesome. Have you got one? I can show them tomorrow. Yeah, I'll show you. It's simple. I've got 14-year-old girls that do it themselves. Yes.
You mentioned before about the form that you sometimes will select with the B12, whether it's the hydroxy, the methyl, or the adenosine. But I don't think we kind of got to sort of the answer on that. So when do you know which form that you're going to give?
So if you have someone who has low blood pressure to start, you would use hydroxycobalamin. If you have someone that has high blood pressure, I would go with methyl. If you have someone with chronic fatigue, I would go with adenosine and maybe a combination of something else, depending on what you thought. If you have someone with COMT++, who you're thinking, oh, I actually am not quite sure whether this person is going to react to methyls or not, I'd rather be safe for now, give hydroxy, because you're not going to get as many side effects. And methylcobalamin will affect patients a lot less than methylfolate. So you don't get the sort of reactions unless they are neurologically really. So if you have someone who has high anxiety and they're quite a full-on personality, I would not give them methylcobalamin. I would give them hydroxy.
What if it's ADHD or something thereabouts?
I'm not afraid to give methyl. No, definitely not, because we know these kids are very reduced in their methylation capacity.
Okay.
But I would be probably cautious, and I wouldn't go in with 2,000 micrograms. I might only go with 500 micrograms and do it every second day.
Okay.
Yeah. Does that answer the question? Okay.
Two quick questions. Oh,
Who am I looking at?
I've got the microphone.
Okay.
I have the power.
I've got a big bright light in my eye.
Oh,
so
sorry. Liposomal B12, methylcobalamin. It seems fantastic stuff. Works really well, but you haven't mentioned it.
No, because I'm often looking at the genetics, and I'm also dealing with incredibly chronically ill patients. My patients are not the norm, right? So they're not just someone that comes in and I think, yeah, a pump of methyl B12 liposomal can be good. I'm trying to really shift something, and I usually will go in and I see, because I can see transcobalamins, so we'll learn more about this over the weekend, but the transcobalamins are your ferrying capacity of B12. If I see a homozygous transcobalamin in any of my patients, I will bypass anything oral and I will go into the injections.
It's almost like injecting it, though, the liposomal.
Well, it is for some people,
Yeah.
and for others it doesn't work nearly as much.
Okay.
But when I've corrected it, I will go back to it. Definitely, either a sublingual or a liposomal, absolutely. But initially, I don't tend to, because I really need to I need to get a result, and I need to get it fairly quickly.
Okay, next very quick question. When you see a person, have they done their genes already? Because when I see
Mostly,
them, they haven't, and that's 2 months. So you've got to guess.
yes.
Yeah.
And that's where understanding these pathways.
Yes.
So I will have a lot, some of my patients, not many, but some of them will not have any genes at all. But I will know from my questioning pretty well what's
What
the
they've
problem.
got. Okay.
Yeah.
So you're guessing, but with good information.
I'm guessing with
Yeah.
10 years of
Yes,
education
that's right.
that says to me 90% of the time if I
Yeah.
think there's a gene polymorphism, there is.
Yeah. Okay.
Yeah.
Thanks.
And I think we had a question. Can we bring the microphone down here?
There's a microphone here. Could we could you
Yes.
just talk more about molybdenum, the doses and the forms that you use,
Yes.
please, and the maximum dose? Or
Yes.
yeah,
So most of the molybdenum, there's not really any straight molybdenum in Australia, unfortunately. So I get my patients to get a thorn molybdenum, and it's a 1 milligram. It is a high dose, but that's really what you need to clear that sulfur and clear it well, quickly. So most of the supplements that you would see would have 100 micrograms, 50 micrograms. I'm going with 1,000, one hit, go. And I will say you probably only need one bottle and you may not need it for another year, but for now, 1 milligram every day until the bottle's finished. Kids, maybe half or one every few days. Yeah. Yeah, don't be afraid, because I mean, the molybdenum works absolute wonders. And if you've got someone with persistent diarrhea and you can't seem to find a solution, the molybdenum and a low histamine diet will usually get rid of it, 100%.
So what do you do when they aggravate on molybdenum?
Where's that coming from? Oh, I actually have never had anyone aggravate on molybdenum.
I have. I've had a lot.
Have you? Yeah, no, I don't. But I'm wondering whether or not it's because they didn't have such a sulfur issue anyway, and that sulfur was too low. So think about that. If they're aggravating and you're reducing sulfur, which we need, it's essential. Then
no change in sulfur. It just seems to they dump toxins very, very quickly, and they get headaches
from any molybdenum.
Yeah.
See,
Very
what I would
sensitive.
say that's actually a sulfur disturbance, and it's probably too low, and you've got to work increasing sulfur, cysteine, glutathione.
I typically put them on NAC first
Do
before I
you?
do anything.
Okay.
And taurine to stabilise
Yeah,
that part.
so they're fine.
Yeah, no, they're fine. They're stable, but they can do a dump. So, and with kids, you've got to be very careful because molybdenum can affect potentially growth hormone levels.
Well, in the autistic, I know in the autistic community they use typically 250, much lower dose. But I don't see a lot of autistic kids. Mainly I'm dealing with adults.
I used to, and I wouldn't go above 125
Yeah, well
for
that's fair.
safety purposes.
That's fair. Yeah, absolutely. I mean, with my small kids, I know Kristen looks after the kids in our clinic, and she does 50 micrograms, much smaller doses. Yeah, good point. Oh, sorry, we'll just the microphone.
I had a patient, he's vegetarian, very low B12. His B12 was 155. So he wanted to have injections. So because I gave him the hydroxycobalamin, and within 5 hours he actually had chest pain. It lasted for 12 hours. He's fine on a liposomal B12, not able to tolerate. I never gave another injection. Sorry.
Was it what was it, intramuscular?
It was intramuscular.
George, would you know why? Can you give the microphone to George, please? Thanks.
Sorry, with the intramuscular, you do get a big spike and then the blood level goes down. With a subcutaneous, you get more of it sort of mimics the way it's in the body. So that's probably why it's probably too high a dose too quickly.
Okay, there you go. So it may not just be the injection, but just the form and the dose. Yeah. Anyone else?
Some
No. George, methylcobalamin in ampules. No, I'm sorry, I don't know. All right, so why don't we move on, because we've still got 39 minutes until morning tea comes out. So let's talk about some of our neurotransmitters. The pathways, where we've got 5 classes: the cholinergic, amino acids that act as neurotransmitters, the adrenergic, which is our epi, serotonin, dopamine, and histamine, peptidergic, insulin, and the glucagons, and our steroid hormones. And essentially, and we're going to learn a lot more about this on the weekend, but we're talking about this part of the pathway, here our serotonin, and here our dopamine. So again, you can see that dihydrofolate reductase is essential for this recycling of our tetrabiopterin pathway. And so we get the conversion of our amino acids, phenylalanine, tyrosine to and our arginine here, which is our nitric oxide. We create our serotonin and dopamine here. Now, so when we get, and this is going to be the Dr. Andrew Rostenberg's presentation, is going the tryptophan steal. And essentially, the premise is that when we have inflammation, lipopolysaccharides, tryptophan is stolen from our serotonin pathway to support this IDO or kynurenine pathway, because this is how we get rid of our bugs. And you would see on your organic acids test that you do that quinolinic acid can be elevated, and this is where we get this NMDA receptor activation. So it's helpful with the organic acids to see if this pathway is being stimulated. It's also B6 dependent. Quinolinic is excitatory, whereas our kynurenine is protective. And you can see that the end result is NAD. So there's our kynurenine pathway, and it's often why in chronically ill people and people with highly lipopolysaccharides and inflammation, they get this reduction in serotonin because there's not enough tryptophan to be converted to 5-HTP to serotonin. And you can see here your sulfur pathway is integrally important, given that we were talking about sulfur in these parts of the pathway. So, and then we get our tyrosine to dopa, which then supports our dopamine part of the pathway. And you can see that all of these major enzymes that do the conversion are iron dependent. So iron and a lack thereof is going to affect conversion. So, and you said, you know, before we've got a lot of methyltransferases in here, and you can see that SAM and magnesium are the cofactors we need for these methyltransferases. You see SAM in all of these. Norepi gives us our alertness, concentration, and energy. Serotonin, our obsessions, compulsions, and memory issues. Here, pleasure, reward, and motivation. So you can, and Dr. Lynch is going to be talking to us about the COMT profile, because dopamine really does determine what we are like, from a neurological point of view. So the more dopamine we have, the more pleasure we have, the more well, I guess it's the opposite really. The less dopamine, the more we seek pleasure, with the more we seek these reward, like these are our addictive personalities, the more we lack motivation and drive. So the COMT plus people who have a slower working enzyme have more dopamine. The people who have the COMT minus have a fast working enzyme, so they lose a lot of dopamine. So these are normally the people that are the drinkers, the smokers. They love their drugs. They love jumping off, out of parachutes, out of planes and climbing buildings. These are the people that are seeking that dopamine. And I think probably the best person that we can I think of, is Michael Hutchins. Think of him, the adulation that he originally got from the audience and everybody clapping and cheering was helping raise his dopamine levels. But after a while, that doesn't become enough. So what does he do? He drinks as well. And then that doesn't become enough. So he takes drugs. And then that doesn't become enough. And he was into the sexual gratification, that risky behavior. And so you often see these people, and one of the first questions that is in my intake form is, have you ever taken any drugs? And I then ask them the question, okay, I can see that you took marijuana for many years. I can also see that you took speed. How did it make you feel? This isn't a tricky question, but I want to know, did you feel good? And they'll go, oh, I just felt awesome. I loved it. I wish I could still do it now, because they were self-medicating. And then you'll get some people say, nah, I just did it to be social. It didn't really make me feel good at all. So I know that these people, particularly when they've got family histories of alcoholism, addiction, their dopamine's low. And so normally you will see a COMT minus, green COMT. And so your objective is to slow that down. Those, though, that have the COMT plus, they're more likely to be the people who are A-type personalities. They're driven. Don't you tell me what to do. They're the ones that you say, well, what I'd like you to do is X, Y, Z. No, I don't want to do it. I've done it before. Don't tell me to do it again. They'll clench their teeth. They'll really tell you off. They're the COMT plus. They're highly driven. They're highly motivated. Just doing what they do every day is what gives them the reward. They don't need to do, in fact, they're quite risk adverse. You won't see them jumping out of a plane. They don't need more dopamine. So our objective with these patients is to make it work better. SAM as a cofactor, magnesium as a cofactor, will help it and clear the dopamine a bit. And then with serotonin, obviously in the lower you can see OCD, particularly seasonal affective disorder, very much a low dopamine, and we'll go a bit more into it. Dr. Rostenberg is going to spend a lot of time on tetrabiopterin and being able to have a look at the recycling of this. This is essential for our redox reactions. It's essential for all our neurotransmitters, cofactor for the synthesis of nitric oxide. So remember we said nitric oxide helps with vasodilation. It's a signaling molecule. We do need it. We don't want it low and we don't want it high. And it regulates our nitric oxide synthase pathways. So MAO, COMT, and our SULTs. So MAO basically helps with serotonin, dopamine, and norepi. And in my case studies, you're going to see how we work the interrelationship between those three to try and work out what's going on with our patients. COMT. So COMT is really important for dopamine pathway, dopamine, norepi, and noradrenaline, and epi. So with the COMT, though, remember it metabolizes toxic estrogens. It makes estrogens less toxic. When we methylate them, they're safer. So anyone with a family history of estrogen dominant conditions, breast cancer, prostate cancer, fibrocystic breast, fibrocystic ovaries, endometriosis, we've got to be thinking is possibly a COMT polymorphism together with a CYP1B1 because they work together. So CYP1B1 gets rid of estrogens, helps cleave the estrogens phase 1. And together with glutathione and COMT, catechol O methyl transferase, we need to make sure that we're clearing these estrogens and making them safer. So COMT, although you've got the positive that they're highly motivated and they're go personalities, they've got the problem with their estrogens. And it can be incredibly empowering for patients to understand that that's why, for example, they ended up with endometriosis. And so does their kids. So being able to say to parents, look, you've got 3 daughters, you've had endometriosis, your mother had fibroids, and your grandmother had breast cancer. We need to make a concerted effort to make sure that you're detoxifying estrogens. So we're really going to work on phase 1, phase 2, we're going to improve the enzyme COMT to make sure that you're doing it better. That's pretty clever that we can do that. And because of the estrogens in our environment at almost every level, we also need to think that perhaps this applies to almost every patient we have. Because we're drinking out of plastic water bottles, we're buying food in plastic containers, we're heating food in microwaves in plastic containers. We've got so many endocrine disrupting hormones that really this has to be our focus. And I was listening to a couple of doctors on a podcast a couple of years ago, and they said, when we started out 20 years ago, we would give someone a tonic for liver function, and they'd come back 3 weeks later and say, hey, I'm feeling pretty good. Now, unfortunately, they said we can work for 1.5 years, 2 years, and we still don't get the results that we got 20 years ago for working with them 3 months, because our liver is completely overburdened at almost every level. And so COMT++ CYP1B1 patients particularly have to be counselled about everything they do. So most women, before they walk out of the house, they're exposed to over 300 toxic chemicals. In the perfume is the worst, absolutely 100% the worst. Their personal care products, their makeup, the products they use in the shower, the shampoos they use. So we really have to make a concerted effort with these patients, that we're saying it is essential that every product you use in your home and on your body and what you drink out of and the way you buy your food has to be really good, because you are susceptible. And I think that's why we've seen such a huge rise in breast cancer rates and prostate cancer rates, because we've got this huge overload of xenoestrogens and we're not really doing anything to support it from a liver percentage. And I guess the number of people that have COMT++, I don't know the actual stats of I can't remember the number of people or the ratio of the COMT++, but we do have to be aware. So I'm COMT plus minus, and I'm homozygous CYP1B1, I ended up with endometriosis at the age of 22. So I have 2 daughters, and so my goal was for them not to have it. So really from the age of puberty, I've been supporting their phase 1 and phase 2 liver detoxification, because I don't want them to end up with, what I had. And I was lucky that I got onto it early, and I had multiple operations, but I was still able to have my kids. But I wish I knew that when I was 20, because I probably could have done a lot about it and not have to go through all of that. And sulfur, it's so important, and that's why these FODMAP diets have to go. We can't be restricting sulfur in our diet for more than 3 weeks at a time. We need it. We have to have it. Neurologically, we have to have it. All our glycosaminoglycans, for our knees and our joints, we have to have it. We have to have it. MAO A and B. So MAO A has a higher affinity for serotonin and norepi, and MAO B a high affinity for dopamine. MAO A and B are X-linked, and they're mitochondrial bound. So here we have MAO B. So when we look at the dopamine, tyrosine hydroxylase converts L-DOPA down to dopamine with the help of the DDC, dopamine beta hydroxylase. Now this is an important enzyme, because for those of you that do the Great Plains work, like methionine synthase, this is inhibited by yeast and Clostridia. And so if we are inhibiting this enzyme, what's happening with dopamine? It's going to rise, because we're not allowing dopamine, and we're going to end up with a reduction in norepi and epi. So we need to be making sure that we are getting rid of, lipopolysaccharides and issues with gut first. So we're clearing that enzyme. And you'll often see on the organic acids report HVA and VMA. Now remember, it's not measuring dopamine and norepi, it's simply measuring marker. So if it's elevated, can you assume that dopamine is high? No. Can you assume that it's low? No. Because you've got key enzymes that are working towards this VMA, and if this is blocked, VMA is probably going to be low. If you've got a COMT++, VMA is probably going to be low. So the organic acids will say to you, the report will say, if you have an elevation in VMA and HVA, it means that there is a block in dopamine beta hydroxylase. It only means there's a problem with dopamine beta hydroxylase if there's excessive amounts of yeast and excessive amounts of Clostridia. You cannot make the assumption that dopamine is low if that is, or that dopamine beta hydroxylase is being blocked if you see that high. So MAO B, you can see all of these are FAD dependent, FAD dependent, FAD dependent. So ensuring that we've got riboflavin is actually really important, because again, it's the cofactor for most of these. So when you see these polymorphisms in MAO and COMT, you can, and circle it on the pathways, you can start to see, because this is most definitely the most complicated of the pathways, and that's why we're talking about it this weekend. Because you will have some people that have high COMT, and you'll have some people that have very low. The very low, the very high COMT activity means they process their dopamine very quickly, and we don't get it to stay in the system, so they're losing it. And the people where this is slow, and you can see that COMT is here, it's here, it's here, it's here, and here. So it's so integral into the processing of dopamine. But you can see dopamine beta hydroxylase, copper, PQQ, and vitamin C dependent. So this is where the copper comes in. Can we always assume that we have to reduce the copper? Because there's our copper. And some people do actually do quite well when we're putting copper back in. But again, why do we always see 99.9% of our patients with high copper? I don't know. I think it's multifactorial, but hopefully we'll learn more about that tomorrow when Dr. Stephanie talks. So key enzymes, A, B, on all the variant reports you can see MAO-A and MAO-B and COMT. So they're good to be able to look at, even if you, these are the Pathway Planner 5s that you can download from Dr. Lynch's site. We'll send you the link for these on Monday, but you've got the basic ones. Now, I haven't actually even seen them yet. Has anyone downloaded them? Yeah, it's $25, but normally it's like $290 for these ones, but they're $25, so it's a bargain. But I will actually download it tonight and have a look at it. I haven't had time, but oh, did it? Oh, oh, really? You got it? Oh, okay. So I'll try it tonight and I'll let you know if it works. Okay, so serotonin, you can see MAO-A plays a part in serotonin. And again, you need that DDC enzyme to be working. Now, people often ask about melatonin, and one SNP that I do see a lot of is AANAT, homozygous. And so what that means is those people don't effectively convert serotonin to melatonin. And these are the people that B5, which is the cofactor, can actually be very helpful. However, look at what inhibits AANAT, BPA. So this is, you know, when you start to see these pathways up close, you can see why environmentally it actually doesn't matter what SNPs you have, because you can, your genes, these enzymes can be affected. This is the epigenetic effect, where we are actually getting the environment shifting how these genes work, irrespective of polymorphisms. Someone was saying in the lecture yesterday, they did a report and saw BPA in the 4000s on one of the reports they did. Now, is that going to inhibit that enzyme? You bet it is. She may have or may not have a polymorphism in AANAT, but it doesn't matter, because with BPA levels like that, she's going to get inhibition of that. And you can see that SAM, now this is an interesting thing with SAM. When I give SAM to someone, usually I do it, again, I go in slow, 100 milligrams, and I say, right, I want you to take SAM. And the important thing to know about SAM is, yes, it's needed for all methyltransferases. My personal point of view is that when you're looking at MTHFR polymorphisms, not COMT++, but MTHFR, I would prefer to use methylfolate and allow the body to produce its own SAM. But if you've got someone who's very ill and getting SAM levels up is going to take you quite some time, but you know that they will benefit from SAM straight away, I use it to see if I can get an effect fairly quickly to improve mood or improve whatever I want to improve. So with SAM, I say to them, take 100 milligrams, see how you feel. You may not get any response from it, but I just want to see what the reaction is. And I want you to take it at night, because 50% of people, when you give SAM, they want to go to sleep. Why? Look at the cofactor for this ASMT gene that converts N-acetylserotonin to melatonin. It's SAM dependent. So some people will take SAM and they literally have to go to sleep. The other 50% will take SAM and feel like an Energizer bunny. Right? So I say to my patients, you're going to get 50-50. I don't know which way you're going to go, but let's see. And if you feel like an Energizer bunny and it makes you feel great, you take it in the morning. And if it makes you go to sleep and you really have to go to bed, you take it at night. And I've got 50% of patients that take it in the morning and 50% that take it at night, because it really makes them feel like they have to sleep. So these pathways, you can see, are really important, and being able to understand what inhibits them, what makes them work faster, really important. MAO. So the MAO inhibitors were the first category of antidepressants ever developed. They're based on MAO-A inhibition, and they've been replaced mostly by SSRIs. And it's interesting because whenever I get someone who's a history of anxiety and depression, I will always say, have you ever taken any antidepressants? And they'll say, yep, but they didn't work. And I say, well, what were you given? I was given an SSRI. Okay, and so how generally were you feeling at the time? Well, I just wanted to isolate myself from all my friends. I wanted to sleep. I had no motivation. I was feeling pretty crappy. I just really couldn't be bothered to do anything. I was pretty down. Was that a serotonin issue? No, it was dopamine. That's the classic sign of someone who has a problem with dopamine. I can't be bothered. If any of your patients say, I can't be bothered, I can't be motivated, I ask them, do you usually finish things that you start? Nah, I've got 50 projects going on. I don't do it. Do you feel like isolating yourself from your friends? Yep. I don't really want to go out. I don't want to see anyone. Do you sleep a lot? Yep, I do. I just love being in bed on my own. That's a real, the motivation is the easiest question that you can ask whether someone has an issue with dopamine or not. And that's why when people say SSRIs just didn't work, I'll go, okay, well, you probably didn't have a serotonin issue at the time. You had a dopamine issue. Ask them what they were like as a student. Were you highly motivated? Did you do all your homework without your dad or mum hounding you to death? Oh God, no, I didn't do any homework. I hated it. I just wouldn't do it. I couldn't be bothered. Dopamine. So many people have low dopamine. My husband is COMT minus, right? And when I first met him, he was working in quite a high-powered industry, so he was is always been quite motivated from a work perspective. But when I say to him, oh, you're going up to meet your mates, and he goes, no, I can't be bothered. Out I get with the tyrosine. Here you go. Here's a couple of tyrosine. Off you go. And he goes, oh, it feels so much better. But he battles me. Your dopamine patients, your COMT minus are the worst bloody patients on the planet. Because you can give them every plan. You can write it out. You can put them in blister packs. You can do everything and they won't bloody take it. I had one of my practitioners in the mentoring group. She had a low dopamine patient. So she said to him, I'm going to ring you every single morning at 7 o'clock and I'm going to get you out of bed and you're going to take your supplements and then you're going to go for a walk. And you know what? To her credit, she rang him every single morning for 2 months. For 2 months. That is an amazing commitment to get him out of bed. So if I know I have a partner or a mum, dad, whatever, who has a low dopamine child or someone there that they've bought, I will say to them, you are a crappy patient. I can tell you right now you're crappy because you're not going to take what I'm giving you. So mum, you have my permission to put it in her hand every morning, and if you don't take it, when you come back here, you're in trouble. That's what I say to them. Because they're not motivated to take it. And the catch-22 is, unfortunately, they need their supplements and their tyrosine or whatever you happen to give them the motivation to take it. So once you get them going, though, they're pretty good. But unfortunately, they're not very motivated to do what you ask. If you give a COMT++ a regime, you can be guaranteed 100% that they are going to do it by the book. And they will do what you ask them to do 100%. If you said, I want you to go and lie in the bath in Epsom salts for 3 hours every day and sip on a cup of tea as you do it, they would do it. And they wouldn't miss a day. That's the difference in the personalities of the patients that you've got. And if you understand that, you can actually understand the motivation that you need to get them to get up and do something. Yeah. Would it be if for the motivation? How would I increase their motivation? So if I was going to try and slow down COMT, I will do a couple of things. So if we go back to our COMT, I certainly wouldn't give them SAM, and I certainly wouldn't give them too much magnesium. We know that rhodiola and green tea will help slow the COMT enzyme. It just slows it down. Have you ever given rhodiola to some patients and they go off their tree? I have. And it made me think at the time, my goodness, what have I done? Like, they've rung me and said, don't ever give me that again. I'm never taking that. You've sent me into a literally maniac. I'm angry. I'm pissed off. And what did I do? I raised their dopamine. They don't need it. But if you give it to someone who is very low in dopamine, they'll love you for it because it feels really good. So we can get green tea, phytosome, we can get rhodiola, and typically I will give, I can't remember the dose of the rhodiola, but I would probably give, I can't say the brand name of the product, but I think it's 500 milligrams. So I'd probably give 1,000 milligrams 3 times a day of the rhodiola, and the same with the green tea. But one of the best things to improve tyrosine is obviously N-acetyltyrosine. Dopamine is tyrosine, and I would give 500 milligrams, probably 2 tablets in the morning and 2 at lunch. You don't want to give it later in the day because it will keep them awake. So that will really, and just giving someone 1,000 milligrams of acetyl-L-tyrosine first thing in the morning can really kickstart their day. But remember, we want to go back further, and if they've got an MTHFR polymorphism, we really have to help the production of neurotransmitters through SAM. So we do want to start to give them some methylfolate as well. So as a rule, COMT minus minus, if I'm going to generalize, they love methylfolate. And particularly if they're homozygous MTHFR, you can go, and I think these are the people who clinically in the States, and we've got new products here in Australia that have 15 milligrams of methylfolate, and they're being used for serious depression. And it's these products that I think that combination of genes works really well for. So COMT minus minus and homozygous MTHFR, I think really they're the only ones that we can safely say that 15 milligrams of methylfolate, one hit once a day, is really quite good for depression. And I've seen it work where just nothing else does. And I have that exact woman in one of my pregnant women, my fertility patients. She had a lot of issues falling pregnant. I met her just after the birth of her first child. She tried 10 years to fall pregnant, finally did it with IVF, and we worked through that first pregnancy, through the first 3 years, and we slowly, she's homozygous MTHFR, and we just slowly increased her folate as the years went on, and she fell pregnant very easily, totally unassisted, no problem, great pregnancy. But we kept her level of folate very high because her mood would drop. And so she just gave birth with her second child probably about 2 months ago. And I got this panicked phone call in the clinic to say she was really depressed. So I got on the phone and I said, okay, what's going on? And she said, oh, and she just burst into tears and she said, I feel like I'm losing it. Okay, what have you done? Well, I don't think I've changed much. And I said, what have you done with your methylfolate? Oh, yeah, I reduced it a couple of weeks ago. Why? Oh, I was feeling really good and I thought I probably didn't need as much. So I literally took it back up. I think she was on 8 milligrams. She dropped it back to 5. I took her straight back up to 8. Within 24 hours, she was feeling 80% better. I then took it up to 10 and she felt even better. So there are some patients that they need more. And I really think that's where that 15 milligram can be very, very helpful for these really chronically depressed, because your COMT minus minus and your MTHFR, they're very, very prone to depression. And you will mostly see a huge family history of depression in that subpopulation. The homozygous MTHFR with the COMT plus, completely different kettle of fish, because you don't want to stimulate methyls too much. So it is a balance. Mm, that's right. Mm. not enough. Yeah, that's right. Yes, because you're typical COMT minus minus. So, rhodiola, acetyl L-tyrosine, more methyls can really help improve mood. Yeah, and I think, we're here to talk about anxiety and depression because it's everywhere. It's in our kids. We've got now my daughters, when they left school, had been to 6 funerals from suicide. They shouldn't be doing that. I've been to one in my whole life. Like, the younger generation are getting more and more depressed. And it's obviously multifactorial. I think it's got something to do with the food and the folic acid. I think it's got a lot to do with our environment and EMFs. They have banned in Switzerland all use of iPads and all in schools because they know that it's not great for the health. So what are we doing? We're getting iPad holders on prams now. Did you know that? There's a connection for the iPad on the pram. Like, really? All these kids at the age of, look, you can't say anything, but my stepson's kids, are 3, 7, and 9. The 3-year-old sits there with an iPad all day, just going through whatever. And I think they can't write. Kids can't write. They've got no idea how to pick up a pen and write something you can read. They can't have a conversation. I went to, my husband and I just recently went to, we ran out of time. We just went to Fiji for a week. And where we stayed, there are a lot of Chinese couples, newlyweds. And I swear to God, we were sitting there having our conversation over dinner. Not one couple, and I'm talking at least 20, they sat there with their phones the whole meal, and the only time they put their phone down was to eat. They then picked up their phone, and I reckon they didn't say 10 words to each other the whole evening. So sad. That's bloody ridiculous. So we've got so many things that are affecting us environmentally that even if you didn't have COMT minus minus, it's affecting dopamine levels. I actually think we've got problems with processing dopamine. We've got road rage out there. Like, how many times are you seeing people fly out of cars and punch people in the head? There was one 2 nights ago. I couldn't believe what I was seeing. This guy came out and punched a guy 15 times in the head. Like, we've got problems with our neurotransmitters, irrespective of our genetics. So I think that's really important to remember that. All right.